Let us talk about this problem. We are given two sorted arrays. We need to print union of these two sorted arrays. Our output should also be sorted. Every element should be printed in the sorted order. Now what do we mean by union? We need to print every element which is present in both the arrays. All the elements of array 1 and all the elements of array 2. And we need to print every element exactly once. For example, here 2 is the smallest element, then we print 2, 3, next is smallest 5, 8. 8 is there in both of the arrays, but we print it once. 9, 10, 15, we print these elements also. Let's see this example. 2, then 3 times, then 4 2 times, and then 4 2 times here. So 2, 3, 4, right? These are the three distinct elements present in both the arrays. So our output is 2, 3, 4. Now please pause this video. Try to write down a function that takes two arrays as input, A and B, and prints union of both the arrays. Let's first talk about a naive solution to solve the problem. The time complexity of this naive solution is going to be m plus n into log of m plus n. M is the size of first array and n is the size of second array. And you might have guessed it, we are going to use sorting here. So what we do first, we create an array C. So this is C++ syntax. In Java, you can create an array of size m plus n this way. Also, if you're programming in Java, you don't need to pass the lengths as separate parameters. You can get m as a.length and n as b.length. After creating the array, we copy the elements of array A into array C. After copying the elements of array A, we copy the elements of array B starting from index m, right? I goes from 0 to n minus 1, so we begin with index m. So we basically first copy the first three elements, m is 3 here for array A into C. Then we copy the four elements of array B into C. So our C has all the elements of array A, then all the elements of array B. After doing this copying, we sort the array C. After you sort the array C, what happens? Your C array becomes 5, 10, 20, all the same elements, they come together, right? See, we want to print the union and that too in the sorted form, right? So, and we don't want to print any duplicates. So we got the sorted form, we got all the elements, we now just need to remove the duplicates while printing. Now we simply traverse the array C, and while traversing, we see if the current element I is not same as previous element, then only we print the current element. See, for sorting, this is C++ syntax. This is how we sort in Java. And for printing, we'll use system.out.print in Java. So that's the simple idea. That's what we are going to get as an output. We have the time complexity this much because of the sort step. This is theta m, this is theta n, this is theta m plus n, but this is m plus n into log m plus n. Also, the solution requires theta of m plus n auxiliary space. Now please pause this video and try to think of a solution that works in theta m plus n time. Let us now talk about the idea for efficient solution. What we are going to do is, we are going to follow the process similar to merge function of merge sort. We are going to traverse both the arrays simultaneously, array A using index I and array B index using index j. And what are we going to do? Like merge sort, we are going to compare A, I and Vj. For example, if I begin from index 0, 0 in both, and if this is smaller, see, we need to print the union in sorted order. Then what you will do? You will simply print AI and you will move ahead in array A. So if AI is smaller, then what are we going to do? We are going to print AI, right? And we are going to move ahead in this A array. We are going to do I plus plus, right? And if so that's how we'll handle 2 and 3. We'll print 2 on the screen, then we'll move ahead. Now we'll compare 10 and 3. So now Bj is smaller, right? I is here and j is here. And when this is smaller, we are going to print Bj and we are going to move ahead in array B. So we are going to print Bj and move ahead in array B, right? J plus plus. That's what we do when they are this way. So we'll print 2 first, then we'll print 3 first. Now we have I here and j here. Now I is smaller, so we'll print 10 and move ahead here. Now we have I here and j here, 20, 20, they are same. So what should we do in this case? See, when they are same, we are going to print one of those two elements, right? Any of those two elements, and move ahead in both the arrays. So we are going to print AI or Bj. You can print anything, that's same. So print AI and move ahead in both. I plus plus, j plus plus. So what will happen now? We'll print 20, right? Because we have printed AI, and we'll move ahead in both the arrays. So we will come to 20 and 40. See, now we need to ensure that 20 is not printed again, right? For that purpose, we need to add some extra conditions. The conditions that we are going to add is if AI is equal to AI minus 1, then we need to simply move ahead and continue, right? Because we have processed the same element already, right? So we do I plus plus and we continue. And same thing we need to do for bj, right? If bj is equal to bj minus 1, then also we are going to do the same thing, right? J plus plus and continue. Also, we need to add a condition that we should check for this only when I is greater than 0. If I is 0, we should not be accessing minus 1. Here also we need to add a condition j is greater than 0. So this is how we are going to write the logic, right? So this 20 will not be processed, it will be falling into this condition and it will be ignored, right? So we reach the end of this array. Now what are we going to do? See, once we reach end of any of the arrays, we need to process the remaining elements of the other array. Same thing we do in the merge function of the merge sort, right? When we finish processing one array, we process the remaining elements of the other array. So now we are going to come to this array and we are going to process 40 and we are going to print 40 on the screen. So now you have complete idea about the solution. Please pause this video and try to write down the complete code yourself. Here is implementation of the idea that we have just discussed. If you take a closer look at this implementation, this is very similar to merge function of merge sort. We have initialized I as 0, j as 0, then we have loop I smaller than m, j smaller than n, and these three conditions are also very similar to merge function. If AI is smaller, then we process AI and we do move ahead in the A array. If bj is smaller, we process bj and move ahead in B array. If they are same, then we print AI here and we move ahead I plus plus and j plus plus. We are only printing AI because we don't want to print duplicates as per the question requirements. And these two conditions extra that we have added, they are also for handling duplicates. If there exists a previous element and if the current element is same as the previous element, then we simply ignore this element. Continue means simply ignore it and move ahead. And same is the case for array B, right? If the current element is same as the previous, ignore it. After we come out of the loop, we have two more while loops like we have in merge function of merge sort, right? If there are elements left in the first array, then process them. If there are elements left in the second array, process them. And again, before processing them, we need to ensure for every element that this is not same as the previous element, right? So let's do a try run of this for this example. We have array as this, B as this, I is 0, and J also is 0. In the first iteration, right, what will happen? These two elements will be compared, right? We will not go inside here because I is 0 and J is also 0. So we'll print 2 on the screen and then we'll make I equal to 1. So now we are here and here. Now we'll compare these two and we'll print 3 on the screen and we are here and here. Now we'll print 10 on the screen, right? And we'll move ahead in this. Now we are here and here. Now 20, 20 same. So we'll come here and we'll print 20 on the screen and we'll move ahead in both the arrays, right? Now we'll compare now in the move ahead in both the arrays, we'll not be comparing because now we'll fall here. This 20 is same as the previous 20. So we are going to simply ignore it and move ahead in this array. That's why I've simply written I equal to 4 now. Now once your I becomes 4 and you check for these conditions, this condition becomes false because m here is 4 and I becomes equal to m. So we'll come out of this loop. After we'll come out of this loop, we'll check if I is smaller than m. Do we have elements left in first array? No. Now, do we have elements left in the second array? Yes, because last time j was 2 and we have size is 3, right? So we'll go inside this loop and we'll do an iteration and we'll print 40 in the screen. And before printing 40, we need to ensure that 40 is not same as the previous element. So we have added this condition both the while loops. And it's always true that both of the while loops will never execute. You will either have extra elements in first array or in the second array. Now, what is the time complexity of the solution? see, either we do increment of I or we do increment of j, and sometimes we do increment of both I and j. And I ranges from 0 to m minus 1, j ranges from 0 to n minus 1. So the time complexity is clearly upper bounded by m plus n. And extra elements also are to be processed, that also come under m plus n, because together the total number of elements are m plus n only. So the time taken is clearly big O of m plus n, and auxiliary space is, you can guess, it's big O of 1, right? Because we are simply printing the elements, we are not storing anything. So auxiliary space is big O of 1. So we have much better solution using March function.